Greetings, dear viewers, to the channel where we explore the boundaries of the possible. Today's topic is not just a scientific hypothesis, it's a direct challenge to all of classical physics and neuroscience. We are going to meticulously dissect the quantum consciousness theory, a radical idea suggesting that our deepest essence, our self, your thoughts, intuition, and subjective experience, is rooted in the bizarre and paradoxical laws of the subatomic world. For decades, the computational metaphor has dominated, viewing the brain as an incredibly complex, yet fundamentally classical mechanism. We believe the brain worked like a network of transistors transmitting electrical and chemical signals. We search for the code of consciousness in millisecond impulses and synaptic connections. And while this approach has led to stunning successes in medicine and technology, it remains hopelessly stuck before the hard problem of consciousness. How can these chemical electric processes give rise to qualia, the raw internal sensation of light, sound, or pain? Why does the process feel like anything at all? Furthermore, neural networks operate at a certain speed, milliseconds, but our subjective experience possesses a wholeness and efficiency that seems to surpass sequential, step-by-step computation. The brain is incredibly efficient at making complex intuitive decisions, and this efficiency is poorly explained by traditional models. It is this explanatory vacuum that drew attention to quantum mechanics. The quantum world, unlike our macro world, is characterized by phenomena that can provide the necessary instantaneous connection and unpredictability. Superposition, a particle exists in all possible states at once. Quantum entanglement, an instantaneous, non-local connection between particles regardless of distance. And quantum coherence, the ability of a large group of particles to act as a single, indistinguishable system. Proponents of quantum consciousness propose that these quantum wonders must somehow be integrated into biological processes to explain the mystery of consciousness. The most famous, detailed, and arguably the most criticized model is the orchestrated objective reduction, OR hypothesis. This revolutionary theory was proposed in the 1990s by two geniuses from vastly different fields, mathematical physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff. Penrose, studying mathematics and logic, concluded that certain aspects of human understanding and intuition, like the ability to grasp truth in a mathematical axiom, cannot be the result of algorithmic computations performed by a classical Turing machine, a regular computer, or neural network. He proposed that a non-computable process must exist in the brain. Hameroff, for his part, suggested where such a process might occur: in microtubules, tiny, hollow cylindrical protein structures that form the skeleton, cytoskeleton, inside every cell, including neurons. According to Orch, these microtubules function as quantum computing centers. Their protein components, the dipoles, are hypothesized to enter a state of superposition, forming vast areas of quantum coherence inside the neurons. This coherence allows a massive number of subatomic events to act as a single unit, which explains the unity of our conscious experience. A key element proposed by Penrose is objective reduction. In this part of the theory, Penrose rejects the standard view of wave function collapse, which occurs through external observation. He asserts that quantum coherence spontaneously collapses, reduces, not randomly, but due to the properties of space-time geometry itself, which becomes unstable upon reaching a certain threshold of mass/energy. This objective, non-computable collapse is, according to the authors, the moment of qualia, the flash of conscious experience. Anesthetics, they propose, work by interfering with this quantum coherence in the microtubules, preventing objective reduction and consequently turning consciousness off. Despite its stunning elegance, the Orch hypothesis faces the most powerful criticism in modern physics: the decoherence problem. Decoherence is the rapid destruction of fragile quantum states due to interaction with the environment. The brain is a wet, warm, 98.6 degrees Fahrenheit, 37 degrees Celsius, an incredibly noisy environment, rich in water molecules and ions. Physicists correctly point out that under such conditions, quantum coherence should break down, decohere in femtoseconds, quadrillionths of a second. This is disastrously short compared to the 25 milliseconds Hameroff estimates are needed for a conscious experience to form. Critics conclude that Orch is scientific fantasy because it violates the known laws of physics regarding the stability of quantum systems. However, the decoherence argument has weakened significantly in recent decades. Using sophisticated spectroscopic techniques, physicists have found that nature has discovered ways to protect and utilize quantum coherence at room temperature. These discoveries come from quantum biology. Plants use quantum coherence in photosynthesis to instantly test all possible energy pathways and choose the most efficient one. Migratory birds supposedly use quantum entanglement in their eyes to orient to the Earth's magnetic field. And even enzyme reactions in our cells may be quantum, utilizing proton tunneling, a purely quantum effect. These examples prove that biological systems are capable of creating quantum pockets protected from heat. This has shifted the focus of quantum searches in the brain away from microtubules, which are difficult to measure, to other structures. For example, studying the quantum effects of ions like potassium, sodium, and calcium as they pass through neuron membranes, which could influence the very moment a neuron fires. If the quantum consciousness theory, even a modified version, distinct from Orch, proves correct, the consequences will be global and revolutionary. First, it would confirm that consciousness is non-computable in the classical sense. Your deepest thoughts and intuitive insights are not merely the result of algorithms, undermining the possibility of creating a truly human-identical AI with current technology. Second, quantum mechanics introduces an element of fundamental unpredictability probability into reality. If consciousness operates at this quantum level, it could provide a scientific foundation for our intuitive belief in free will, liberating us from the rigid determinism of classical physics. Finally, the active use of quantum entanglement in the brain opens the door to speculation that our consciousness is non-local and, to some degree, interconnected with the consciousness of others or even the entire universe, echoing ancient mystical traditions. Thus, the quantum consciousness theory is not simply an attempt to invoke magic to explain the unexplained. It is a serious challenge based on the mathematical and physical limitations of traditional models. It forces us to look at the brain not as a machine, but as a boundary between two realities, the classical, predictable one, and the quantum, paradoxical, and creative one. While there is currently no direct, unambiguous experimental evidence that the brain operates according to quantum mechanics to create consciousness, the growing body of confirmation of stable quantum coherence in other biological systems makes this hypothesis increasingly plausible. Our journey to fully understanding consciousness is just beginning, and it may lead us to a complete reevaluation of what it means to be human. Thank you for joining me in this incredibly deep exploration. Share your thoughts in the comments. Do you believe your brain is a quantum computer? See you in the next video.